In this video, we're going to talk about kinetic molecular theory, which is a theory we have to explain why gases behave the way they do. And we have three assumptions for this theory. One, particles are so small they don't even take up volume. And this is an okay assumption because let's talk about STP. Let's talk about 1 mole of argon atoms at STP. They take up 0.01% of that volume, the actual atoms themselves. So we can basically say they don't take up any volume at all. The second assumption is that kinetic energy, the average kinetic energy of these gas molecules, is proportional to temperature using the Kelvin system, saying the hotter it is, on average, the more kinetic energy they have. The colder it is, the less kinetic energy they have. And this is a very valid assumption. Notice when we say kinetic energy, we're not talking about movement speed. Although we can relate the two because kinetic energy is equal to 1/2 mass times velocity squared. But here we're talking about energy, kinetic energy, not velocity. Our third assumption is that when two gas molecules hit each other, or when they hit a wall, their behavior is elastic. That is, they act like billiard balls. They hit each other and they do not lose any energy whatsoever. They can exchange energy, so if one fast gas molecule hits a slower molecule, the fast one can slow down and the slow one could speed up. But they don't just crash into each other and stick to each other. That's an inelastic collision. We're going to say they act like billiard balls and have elastic collisions. And that's also a valid assumption. So, in a previous video, we talked about our three simple gas laws: Boyle, Charles, and Avogadro. We showed how we combined those three laws to make the ideal gas law. Now we're going to talk about why those laws actually make sense, why they are laws. So first we have to bring back this idea of pressure that we covered in the first video of chapter 5. We said pressure equals a force divided by an area. Now Newton's second law says force equals mass times acceleration. So gas molecules have a mass, gas molecules have a speed, so they have a force. So according to kinetic theory, gases are always in acceleration. So that's how we're going to begin this talk. Now let's look at Boyles Law. Boyles Law says pressure and volume of a gas are inversely proportional. And remember, we said pressure equals force divided by area. For Boyle's law, temperature and the amount of moles of a gas is held constant. Therefore, when you decrease the volume, you're taking the same amount of molecules but putting them into a smaller space. When you put them into a smaller space, more molecules will collide with the container at any one instant. That means you have the same force but over a smaller area. If the numerator stays the same and the denominator decreases, that means pressure is going to increase. So imagine that you have a bunch of billiard balls that are moving all by themselves. They're flying all over the room. And you take them and you put them into a tin can. They're going to smash the side of those tin cans because they're in a smaller space. So they're going to hit the sides more often. And so when you decrease the volume of a gas, they hit the walls more often. And so you increase the pressure. Now let's look at Charles' law. Charles' law that says volume and temperature are directly proportional. Increase the volume, increase the temperature. Here we're saying pressure and the amount of stuff is held constant. Well, kinetic molecular theory says when we increase the temperature, we're increasing the kinetic energy, and we're also increasing the speed. Remember, force equals mass times acceleration. So for these gases, the mass is staying the same. But if we're increasing the temperature, we're increasing the acceleration. So the force of these collisions are increasing. Now we said pressure doesn't change, but force is increasing. So for force to increase and pressure to remain the same, we have to increase the area that this force is hitting, or another way to say that is to increase the volume. So this is showing kinetic molecular theory explaining Charles's law. The last law is Avogadro's law, where we say the amount of stuff, or the amount of moles, is proportional to volume, where temperature and pressure are held constant. Kinetic molecular theory says if we have more particles, we will have more collisions. Remember, go back to our definition of pressure. Pressure equals force divided by area. Therefore, if we have more collisions, we will have more force. And like our previous law, if pressure is to remain the same, our area of these forces have to increase with the force. So that means our volume is increasing as well for Avogadro's law. The last law we're going to talk about is Dalton's Law. So Dalton's Law was that the total pressure of a gas is simply the sum of the partial pressures of the components. That is, all the pressures of the component gas makes up the total pressure. And the gas acts identical, they are identical to each other, and they're also independent of each other because they're ideal gases. They don't see each other, and they don't take up a volume anyways. And that's what kinetic theory says. Gases are so small they don't interact. So, if that's the case, the only difference between gases is their masses. So, when you add gas components to an ideal gas mixture, it really doesn't matter what gas it is. It could be argon, could be oxygen, could be helium. The only thing that matters is how many of these gas molecules you're adding. And so that is why we get Dalton's Law, where it says partial pressure is just the pressure of, total pressure is just partial pressures. And you go back to the video on Dalton's Law, we said partial pressure is equal to the number of moles of a gas. And kinetic molecular theory explains why that is. Okay, that's our video on kinetic molecular theory, and I'll see you in the next video.